Work done by a magnetic force on a charged particle. Here, the concept that we are going to use is from work energy theorem. Work done is equal to change in kinetic energy. If change in kinetic energy is zero, it means work done must be zero. The same we are going to prove. So we know that F equal to vector F equal to Q V cross B. Now we have to check the work done. So for that we find F dot V. So F dot V equal to here Q V cross B dot V. From vector triple product, we know that A, B, A is equal to 0. It means here, since two vectors are same, then the result will be 0. So F dot V equal to 0. We will study this concept later on in mathematics. Now, we know that F equal to MA and A is dV upon dt. So we write M dV upon dt dot V from here F into V. So equal to 0. Now we multiply and divide by 2, or we write it twice. So we can write it as M by 2 and dV upon dt dot V plus V dot dV upon dt. The same thing is repeated, equal to 0, or M by 2 d upon dt of V dot V equal to 0. If you remember product rule, vector d dot vector v are two functions are there, fx, gx, then we differentiate them in order. So m by 2 d upon dt of v dot v equal to 0. So we can write it d upon dt of half mv square equal to 0, which is kinetic energy. So further we write d upon dt of kinetic energy, just write as k equal to 0, which implies k is constant. Here, due to magnetic force, kinetic energy is not changing. It means work done must be 0. Let's go to next concept, velocity selector. Here concept is an arrangement used to select charged particles of a particular velocity out of a beam in which the particles are moving with different speeds is called velocity selector. Here there are two sets. This is electron beam that is passing through crossed fields. Crossed field means here this is positive charge, positive plate, and this is negative plate. It means electric field is there in perpendicular downward direction, and here cross indicates that there is magnetic field in perpendicular down direction. So electron beam passes. Due to electric field, this beam will be reflected in this direction, and due to magnetic field, this beam will be reflected in this direction. Certain electrons will pass undeflected. They will go straight, and for that purpose, the force due to electric field and force due to magnetic field must be same. So we can say that QE, force on charged particle due to electric field, must be equal to QVB, force on charged particle due to magnetic field. So QQ will cancel out, and from here we will get V equal to E upon B. Thus, electrons having velocity equal to E upon V will go undeflected and others will get deflected. Let's do a numerical question. An electron beam passes through a magnetic field of 2 into 10 power minus 3 Tesla and electric field of 1.0 into 10 power 4 volt per meter acting both simultaneously. If the path of the electrons remains undeviated, calculate the speed of the electrons. If the electric field is removed, what will be the radius of the circular path? So let's consider its solution. So now let's understand its solution. So we know that for undeflected beam means undeviated beam, QE must be equal to QVB or V equal to E upon B. We put the values. Electric field is given as 1.0 into 10 to the power 4 and the magnetic field is given as 2 into 10 to the power minus 5. So this will be equal to 5 into 10 to the power 6 meter per second. So this will be the velocity of electron beam. Now, when electric field is removed, then magnetic field will cause circular motion. So we can say mv square upon r must be equal to qvb or r equal to mv upon 2b. We put the values. So r equal to mass of electron, that is 9.1 into 10 to the power minus 31 into velocity. We have just obtained 5 into 10 to the power 6 divided by charge on electron is 1.6 into 10 to the power minus 19 times magnetic field is 2 into 10 power minus 3. Now we simplify. So we can write it 91 into 5 divided by 16 into 2 into 10 to the power minus 31 from here plus 6 plus 19 plus 3. So it will become 1.43 into 10 to the power minus 2 meter or 1.43 centimeter. R equal to 1.43 centimeter, which is our answer. Thank you for watching.